Welcome to the 10th lecture on ECD. We're going to study high frequency response. And in fact, we started studying high frequency response in last lecture. And we computed this formula for upper cutoff frequency using 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 the input RC network. One over 2 pi R in and C total in. Right. So this is the formula we computed in last lecture to compute the upper cutoff frequency due to input RC network containing resistors R1, R2, the source resistor RS, and beta times this small re, where Rin was, it's a recap from last lecture, Rin was computed as Rs in parallel with R1, in parallel with R2, in parallel with beta Re, where C in total is the junction capacitance on the input side, the junction capacitance between base and emitter terminals, and plus the junction capacitance between base and collector terminal times 1 plus AV, and this was computed using Miller's formula. Right. So given this circuit, we are going to solve an example where we are given numerical values of all these resistors and capacitors, and we are given CBE and CBC and beta, and we have to compute this upper cutoff frequency due to input RC network. So this is today's task. So the values given are 22K R1, this is 4.7K, RE is 470 ohms, RC is 2.2K, this capacitor is 10 micro, input coupling capacitor is 10 micro, this capacitor is also 10 micro, where R2 is 4.7K. And beta is given to be 125, whereas CBE is given to be 20 picofarad, CBC is 2.4 picofarad. 2.4 picofarad. So what we are required to compute is this. The upper cutoff frequency, this one. So given all this, first we have to compute Rin and then C total. To compute Rin, we know Rn is R1 in parallel with R2 in parallel with Rs. Rs is also given to be 600 ohms. In parallel with beta times Re. So everything is known, R1, R2, Rs, and beta, and there is only one unknown, small re. If we know small re, we can compute Rn. To do that, we know that small re from EDC, electronic devices and circuits, we know it is V thermal over IE, where V thermal is 26 millivolts. over IE. And this is DC current IE flowing through the emitter terminal. How would you do that? How would you compute that? For that, to find the the current through emitter terminal, if we know the voltage drop across RE and if we divide that by RE, we can find IE. But to find VE, we have to find VB. And then by subtracting 0.7 from VB, we can get VE. So we'll start from VB, and according to the approximate analysis studied in EDC, the last course, this voltage VB is assumed to be the voltage across R2, assuming that VCC is divided between R1 and R2 and there is negligible base current. So if you put the values in, we know R2 4.7K, we know R1 22K, we know VCC. VCC is also given, it's 10 volts. So plugging these values in gives us VB is equal to 1.76 volts. So VE should be, once we have computed VB, VE can be computed as VB minus 0.7, because there is a voltage drop between base and emitter. The voltage drop is 0.7 volts. So this comes out to be 1.06 volts. And then we can compute RE because we know VE. So IE is VE over RE. So VE is 1.06 divided by RE, 470 ohms. So IE comes out to be 2.26 milliamperes. So now we can compute small RE by plugging this value 2.26 milliampere into it. So we are running out of space. Okay. So once we have computed RE, that is 26 over 2.26 milli, it comes out to be 11 ohms. It comes out to be 11 ohms. So Rn is R1 in parallel with R2 in parallel with Rs in parallel with beta Re. So R1 is 22K in parallel with R2, 4.7K in parallel with Rs, 600 in parallel with beta times Re, 125 times 11. So Rin becomes 378 ohms. So this is the first requirement for behind FCU. To compute FCU, we have fulfilled one of the two requirements. The other is to find C total. For that, we have to compute AV. Because why AV? Because C total is CBE, which is given, plus 1 plus AV times CBC. So we have to compute AV because CBC and CBE are given. We know that AV, the magnitude of AV for this circuit is RC in parallel with RL divided by small re. This capital RE is not included because it is being bypassed by this 10 microfarad capacitor. So plugging these values in, RC, RL and RE just computed, AV comes out to be AV comes out to be 9, B is equal to 99, we can compute C total. And that will fulfill the second and the last requirement to compute FCU. CBE is given to be 20 pico plus 100, because AV is 99, 99 plus 1 is 100 times CBC, 2.4 pico. So this comes out to be 260 picofarad. So now we can put C total here, C total in on the input side, 260 pico. So the final part is we have to compute FCU. We have to compute FCU by putting 1 over 2 pi. Rn is 378 times C in total. We just computed 260 pico. So the input, so the upper cutoff frequency due to the input RC network comes out to be 1.62 megahertz. So this is actually on body plot, it seems like this issue. So this is one of the upper cutoff frequencies we have computed using input network. In the next lecture, we'll learn how to compute the upper cutoff frequency due to the output RC network. Thank you.